Good morning, students. Today we are going to discuss the last part of exercise 9.3, that is the sum number 13, 14, 15 and 16. So this is sum number 13. In sum number 13 it says ABCD is a trapezium with AB parallel to DC. A line parallel to AC intersects AB at X and BC at Y. So we have a trapezium ABCD and a line parallel to AC meet AB at X. So AC and X, Y, B, A, C, D. Prove that ADX and ACY is the areas are equal of this triangle ADX and ACY. We have there is a hint given, that is join CX. That means we have to join the CX. So the diagram is something like this, and if we draw without the being freehand, so the diagram is this. So it can be observed that ADX and ACX lie on the same base AX. So the diagram is, the triangles that we are going to consider is like this: AX, D and C. So ACX and ADX lie on the same base AX and between same line AB parallel to DC. So since it is a trapezium, AB is parallel to DC, it is already given, so these two areas are equal. Now ACY and ACX. So now we have another set of triangle ACY. So this is ACY and AXC is like this. So its a common base is AC and they lie between same parallel line AC parallel to AX. So AC and AX are parallel, that is given in the question. So the area of ACY and ACX are equal. Now from these two equation, the right hand side part are both same. So we can write the left hand side part equals to the left hand side part. So area ADX is equals to area ACY. Proved. So here we have to consider which triangles that we are going to use for each of the equation, hence to get the proving. Now this is sum number 14. Here it says AP is parallel to BQ and parallel to CR. We have to prove that AQC, so AQC is like this and PBR is like this. So here AQC and PBR are equal. These two areas are equal. This we have to prove. So let's go on with the proving. Here is a trapezium. On the top we have A and B. So here it is A and P, which has been constructed by the taskbar. Here we will consider first the triangle AQB. So from the first top trapezium we will consider AQB and PBQ, which lie on the same base BQ. Both the triangles AQB and PBQ lie on the same base BQ and between same parallel lines AQ parallel to BQ. So we can see the areas of the triangle are equal. Next, when we come to the bottom part, here we are also going to consider BQC and BQR. BQC and BQR lie on the same base BQ, as we can see, and between same parallel lines BQ and BR. So we can say the areas of these two triangles are equal. Now we will add 1 and 2. On adding AQB with BQC, we are going to get AQC, and with PBQ and BQR we are going to get the area PBR. So first we have separated the trapeziums, then we took individual triangles, we made them equal, we got four such triangles which are equal to each other, and then add these four triangles. The left should be added to the left so that we get AQC, and the right should be added to the right, that is we have to get PBR. So our sum number 14 is proved. Now sum number 15. Here the diagonal AC and BD of a quadrilateral ABCD intersects at O in such a way that, so we have a quadrilateral like this, A, B, C, D intersects at O, so that AOD and BOC are equal. We have to show that this quadrilateral is nothing but a trapezium. So either of the side we will show it equal. So here is the diagram. Since the quadrilateral we have to show is kind of a trapezium, so we have taken the quadrilateral quite similar to the shape of the trapezium. Now here it is given that area AOD and BOC are equal. Now this part the part BOC we have to add to the given equalities. So the AOD plus BOC will give you ADB. So this is your ADB, and with BOC and AOB we will get area ACB. So we have area ACB. Now these two triangles are areas are equal and have they lie on a same base. Same base is AB. So we can say this line AB and DC are parallel to each other. So we know the triangles are on the same base AB having equal areas, so to each other, lie between the same parallel line. So these triangles lie between the same parallel line. The parallel line is AB parallel to CD. Since AB is parallel to CD, we can say ABCD is a trapezium. So it's very easy, the last four sums, and this is sum number 16. Here we have DRC and DPC are equal. Area of DRC and DPC are equal, and from here we have to show that DCPR is a trapezium. So we are going to prove this by the way we have done sum number 15. Again we have BDP, this full triangle is equals to ARC, this full triangle. Now the full triangle are equal. We have to show ABCD is also a trapezium. So let's go with it. So here is our diagram, and it is given that area DRC, that is the bottom part, plus is equals to DPC. So these triangles are equal and they lie on the same base DC. DC is the same base. Since the areas of the triangle are equal and they lie on the same base, hence we can say they lie between same parallel lines. What are the parallel lines? DC is parallel to PR. Since DC is parallel to PR, we can say DCPR is a trapezium. So this part, that is DCPR, we have to show it is a trapezium. We have shown. Next we have to show that ABCD is a trapezium, but it is given that area BDP, that is this full area BDP, is equals to the left hand side full area of the triangle ACR. Now from these two parts we are going to individually subtract. From BPD we are going to subtract DCP. So here it is, and on the left hand side ARC we have to subtract DCR. So we will be left with, on subtraction we will be left with the top quadrilateral. Here BDC is equals to ADC. So the top triangle BDC BDC is equals to ADC. Since the areas are equal, they lie on the same base CD. So we can say they lie between the same parallel lines. What are the parallel lines? The parallel lines are DC is parallel to AB. Since DC is parallel to AB, we can say that ABCD is a trapezium. So our all the four sums are done, and I hope this tutorial is helpful for you. Thank you.